What if I told you that the same laws of physics that govern the swirling of galaxies and the jiggling of atoms could also predict the next big stock market crash? It sounds like science fiction, but it's a very real and revolutionary field of science called Econo-Physics. Today, on G Fun Facts Online, we're diving into the invisible forces of the market and how physicists are unlocking its secrets. An invisible force ripples through global financial markets, capable of creating fortunes and wiping them out in the blink of an eye. For decades, traditional economics has sought to understand and predict these powerful currents. But what if the key lies not in economic theory alone, but in the fundamental laws that govern the physical universe? Enter Econophysics. The field emerged in the 1990s, pioneered by physicists who were intrigued by the complex behavior of financial markets. They noticed that the fluctuations in stock prices and the collective behavior of traders often resembled phenomena seen in statistical physics. At its heart, Econophysics views the economy as a complex adaptive system. This means it is composed of many interacting agents, individuals, companies, and institutions, whose collective behavior gives rise to the macroeconomic patterns we observe. This is different from some traditional economic models that assume perfectly rational actors and market equilibrium. So how does it work? Well, econophysicists borrow some powerful tools from physics. Think about how scientists understand a gas. They don't track every single atom. Instead, they use statistical mechanics to understand the collective behavior. Econophysics does the same for the market, looking at the collective behavior of traders to understand market trends. They also saw that the random up and down dance of a stock price looks a lot like Brownian motion, the jittery, erratic movement of a speck of dust in water. And then there's network theory. Picture the financial world as a giant, intricate spiderweb. Banks, funds, and companies are all connected. Network theory lets us map this web and see which threads are so important that if they snap, the whole web could collapse. This isn't just theory, it's exactly what happened in the 2008 financial crisis. To model this, physicists use some ingenious tools. One of the most prominent is the Ising model. Originally, it was created to explain how a magnet works. In a magnet, you have tiny atomic spins that can point up or down. They influence their neighbors, and when enough of them align, you get a magnetic field. Now, replace atomic spin with trader. A spin up means buy. A spin down means sell. Traders are influenced by what others are doing. A herd mentality. A big news story can act like an external magnet, pulling everyone in one direction. This model helps explain how speculative bubbles and sudden crashes can form from this collective alignment. They also use something called agent-based models. This is like creating a video game of the economy. They program a virtual world with different types of digital agents. Some are fundamentalists who buy based on a company's real value. Others are chartists who just follow trends. By letting these virtual agents interact, they can watch market crashes and bubbles emerge from the bottom up and even test how a new regulation might prevent a disaster. And this isn't just an academic exercise. Many mainstream models completely missed the 2008 crisis. But some econophysicists, like Didier Sornet, were ringing alarm bells about a housing bubble as early as 2005. After the crash, network theory showed exactly how the failure of one bank, Lehman Brothers, could trigger a domino effect across the globe. It helped shift our thinking from too big to fail to too central to fail. A small but highly connected institution can be just as dangerous as a giant one. And today, Econophysics is being used to understand the wild, volatile world of cryptocurrencies, a perfect playground for studying herd behavior and digital bubbles. Now, not everyone is sold. Many traditional economists argue that you can't just treat people like particles. Human psychology, culture, and institutions are complex and can't be reduced to simple physical laws. And that's a fair point. But econophysicists fire back that traditional models, with their assumptions of perfectly rational people, have their own huge blind spots. The most productive path is probably somewhere in the middle. The two fields are starting to learn from each other, creating more nuanced models that blend the empirical power of physics with the human realities of economics. So what's next for Econophysics? The future is incredibly exciting. Imagine combining these physics models with powerful artificial intelligence. I could sift through mountains of data to spot the faint, early warning signs of a crisis before it ever happens. Some are even exploring the bizarre world of quantum mechanics to build quantum finance models that might better capture the true uncertainty of the market. Econophysics gives us a powerful new lens to look at the global economy. By treating it like a natural phenomenon governed by universal patterns of complexity and collective behavior, we get one step closer to understanding the invisible forces that shape our world. It's a reminder that sometimes the biggest secrets of our own creations are hidden in the fundamental laws of the universe itself. Thanks for tuning in to G Fun Facts Online.